In this unit, we're going to study polynomials. In this lesson, we're going to look at difference of squares factoring.
Okay, hi everybody. In this lesson, we're going to look at factoring, but we're going to look at factoring of something called a difference of squares. Okay, so just think about this. In previous lessons here, we've looked at greatest common factors. We've looked at trinomial factoring, okay, where there's three terms, and then we break them up into two binomials multiplied together. We've looked at trinomial factoring, where the leading coefficient isn't one. And to do that one, we used a method called decomposition, and that used grouping, which is a method that we use when you've got four terms. This one here, this method is going to apply when we've got two terms. And one of them has a minus sign, okay? So, and only one of them has a negative sign. So there's a subtraction in between those two terms. Now, both terms must be perfect squares. Okay, they've got to be perfect squares. But when this happens, you've got a nice little bit of factoring that can occur here. So now just a little bit of background on this. Conjugate binomials, just so that we have an idea here. Conjugate binomials are binomials that have the same exact terms, except the middle signs are different. So x plus 3, x minus 3 are binomial conjugates. And look what happens when we multiply them out. Okay? When you multiply those out, so, and remember, we're distributing here. So the x gets multiplied by the x, so we get x squared. So we squared the first term. And then x times negative 3 is going to give us this negative 3x. 3 times x is this positive 3x. And then 3 times negative 3 is a negative, but then I get 9. And 9 is a perfect square. Okay, so I'm getting perfect squares because the first terms are the same. The last terms are the same. Now, granted, the last terms have different values here. There's a positive 3, there's a negative 3, there's a positive, an addition in one, subtraction in the other. But the number there is the same. So when I multiply those out, I'm getting a square here, I'm getting a square here, but the middle terms have opposite signs. So 3x, positive 3x minus 3x, they cancel, and so you're just left with x squared minus 9. So because this can become this, when I expand it, this becomes this when I factor. Okay? So let's say I start with 4x squared minus 9. So the first thing I'm going to notice here is I've got two terms. I've got one negative, so I've got subtraction here. Okay, and then again, 1 is negative. And they're perfect squares. So what I got to do is I got to find the square root of both of those. So the square root of 4x squared is going to be 2x, and the square root of 9 is 3. So then I just write them in terms of conjugates, binomial conjugates. So 2x plus 3, 2x minus 3. And then I've got it done. I factored. And I can double check that just to see if that worked out to be correct here. And I just do that by distribution. So 2x times 2x will be 4x squared. 2x times negative 3 is negative 6x. 3 times 2x is positive 6x. And then 3 times negative 3 is negative 9. And again, those middle terms are going to cancel when you're left with 4x squared minus 9. So yeah, that works. So here we go. Just a quick rundown of the steps here. So first, we're going to factor out the greatest common factor if possible. And you'll notice if you've gone through like the other videos here, we always do that. We're always taking out the greatest common factor first. If there's a negative leading coefficient, we're dealing with that first. We're factoring it out here. Then we look at the number of terms that we're left with, and if you see a square minus a square, we break it apart into square root plus square root minus square root. Okay? And so that's what each one of these things is talking about here. Okay? Make one bracket the subtraction, one bracket the addition there. Okay, so they're conjugates. And then always check to see if there are any remaining factors that can be further factored out here, because you might not have caught all of the common factors there. You can always check by expanding your work. Okay, so it's actually not bad. This is not a really, really hard form of factoring. In fact, this is quite useful here. So let's take a look at some examples. Okay, here we go. Let's do some factoring. Now, I look at again, I'm going to walk through kind of how I think this thing through here. I look at the question here, and I got two terms. So that's a good sign that this is a difference of squares. And in particular, I'm noticing that one of these is negative, one of them is positive. Now, just so that you know here, just a little note maybe I'll make up here at the top here. X squared plus 4 cannot be factored. Okay, I just want to make sure that this is clear here. There is no sum of squares factoring. Now, that is a comment that's mostly directed at students because you're in high school right now doing this stuff. When you get to university, you'll actually find that there are circumstances where that would work. Okay, that you could make that work, but not here. So let's take a quick look at this. So I know I'm going to break this thing up, and now first of all, I'm looking at and seeing if there's anything common, and there is nothing common between those two, so we're okay. So I'm going to break this up into binomial conjugates. The square root of x squared is x. The square root of 4 is 2. I make one negative and one positive, and I'm done. That's it. That's as easy as it is. It's awesome. So here, I notice I've got two terms. I've got subtraction between them. Is there anything I can factor out of those two terms? Well, no, there's nothing common. So I'm going to set up my two binomials. The square root of b squared is b. Square root of 81 is 9. I'm going to make the one negative and one positive. That's it. Now for this next one here, okay, well, it doesn't work quite that way. First thing I'm going to do here is I'm going to take out the common 2. And I'm going to get x to the 4th minus 64. And it might not be abundantly obvious here, but yeah, now I'm looking at a difference of squares here. Might have to think about that just for a second, but the square root of x to the 4th is going to be x squared. Now, the square root of 64 is 8. And this would be negative 8, positive 8. Excellent. Now, before I go on, though, I got to think here for a second. Now, look at this. Look what just popped up here. This particular factor has two terms. There's subtraction in between. The question is, are these both perfect squares here? Well, x squared is definitely a perfect square, but 8 isn't. 8 isn't a perfect square. So I'm not going to move forward with that. Now, I could move forward by throwing like the square root of 8 somewhere in my problem, but I don't want to make this more complicated than it needs to be. But this was a consideration. That was totally a consideration. You're going to see something pop up a little bit later here in just a moment where we can go another step here. Okay, let's take a look at D. Two terms, perfect. One of them is negative, awesome. Is there anything common? Well, no. 25 is 5 squared, 49 is 7 squared. There's no common factor here. So I can break that up. And as I was just doing there, 25x squared, the square root is 5x. 49, its square root is 7. And again, I make one negative and one positive. Now, you might notice that I've habitually made the first term negative and the last term positive here. That's not necessarily the way that has to work here. That's just a personal preference. There are questions where it just makes things just a little bit easier, okay, if that first one is negative. It doesn't really make a difference, but that is a consideration, just a little one there. This one, okay, 10x squared z minus 360 y squared z. Okay, well, there's definitely a 10 and a z common. Looks like that's it. So that's going to leave us with x squared minus 36y squared. Still got to write those factors that I pull out here, but now I've got two terms, subtraction in between. They're perfect squares. Here we go. So square root of x squared is x. Square root of 36y squared will be 6y. And I'll make one negative and one positive. Over here, 16x to the 4th minus 81. Again, two terms, which is great. One of them is negative. There's nothing common. So here we go. We're going to break that apart here. Now, the square root of 16x squared is going to be 4x squared. And the square root of 81 is going to be 9. Whoops. So I'm throwing the negative in there a little bit earlier. Normally, I would have done that afterwards. Now, awesome. That's fantastic. But when I do that, notice that I have a term here. I do have a factor there that's got two terms. One of them is negative. Okay, you have two terms. One of them is negative, and they're both perfect squares. So it turns out I can actually break this one up a little further. Now, the 4x squared plus 9 can't be broken up because, like we wrote up above here, there is no factoring that is sum of squares. So that's as far as this can go here. This last one here, that's a dead end. But here I have a little bit of play here. The square root of 4x squared is 2x, and the square root of 9 is 3. And again, I make the first one negative, or it doesn't really matter which one's negative, but I typically make the first one negative and the second one positive. So there you go. Now here, there is nothing wrong with the fact that this is written as 4 minus 100x squared. I can totally factor that, but I don't really like how it looks. What I want to do is I want to write this in standard form, so it looks more like that. But then I don't like having that first term being negative, and I don't like the common factor of 4 there. So I'm going to take out the negative 4, which is going to leave me with 25x squared minus 1. I did not have to do it like that. I could have left it there, but this just makes things a little bit nicer for me. If you make the math look good, if you make it look kind of pretty here, it will typically treat you well, okay? If you put it in standard form, it just becomes a little bit easier to work with. So now I've got two terms, subtraction in between, both perfect squares. The square root of 25x squared is 5x. Square root of 1 is 1. And make one negative and one positive. And there you go. I hope that gives you confidence moving forward with difference of squares factoring. You'll find that often as teachers, if we want a question to be just a tad more challenging, okay, not a lot more challenging, just a tad more challenging, oftentimes we'll incorporate a difference of squares bit of factoring in there just to give it one extra step of algebra there. So this is something that you really want to be on the lookout for. It's a common little bit of factoring that teachers use.